All right, here we go. Sorry about that. All right, so x goes in and y comes out. Linear functions. I filled it all in for you because I'm pretty sure you guys all know all this already, but a linear function by definition is a function that can be written in the form f of x equals mx plus b. All right, it's a degree 1 function, which means the highest exponent on a variable is 1, right? There's no x squares involved yet. There's no x's to the third. The only power that we work with is 1. All right, the domain of a linear function. Well, guys, in a linear function, you're not dividing by a variable. You're not having a number, a variable under a square root. So there's nothing bad that could happen to that function. So the domain of a linear function is all real numbers. Plug any number you want into a linear function and nothing bad can happen. I mean, think about it. The graph of a linear function is a straight line. The line is continuous. It doesn't have any jumps or points of discontinuity on it. It's a nice, smooth, continuous curve. All right. Well, guys, just to remind you, because we're going to talk about this in your homework, I believe, a straight line. Let me just wait until I'm in better earshot. A straight line can do 4 things. It can slant in 4 different directions. If you are a straight line, 4 things can happen. The first thing that can happen is it can rise and slant to the right. If you are a line that rises and slants to the right, it's because your slope has to be what sign? Only what kind of slope slants to the right? A positive, right? A number greater than 0. The slope has to be positive. All right, if you are a positive sloping line and you slant to the right and rise, then that is said to be, as x gets bigger, what is y always going to be doing? Getting bigger. So it's an increasing function on the life of its entire domain. So it's an increasing function on its entire domain, which is negative infinity to infinity. All right? The second thing a straight line can do is it can fall, and it can slant up to the left. So if you are a falling line, it's because your slope was negative, less than 0. You have to have a negative slope in order to fall or slant to the left like that. So if you are a falling line, then it's said to be, as x gets bigger, what is y always going to be getting? Smaller. So it's a decreasing function on its entire domain. And again, whenever it says on, this is assumed to be an interval of x values, on the interval of x from negative infinity to infinity. All right, the third thing a straight line can do is be horizontal. Those are our 2 special straight lines. You can be a horizontal line. If you are a horizontal line, it's because your slope is, anybody remember what the slope of a horizontal line has to be?
It has to be 0.
0. It has to be equal to 0. Right, it's a flat line. It doesn't rise. It doesn't fall. It's completely flat. The slope is 0. Which means if the slope is 0, it just means as x gets bigger and bigger and bigger, what does y do? It stays the same. It stays constant. This is known as our constant function. No matter what number you plug in, the same number just keeps coming back out. It's a constant function on its entire domain. All right, and then the fourth thing a straight line can do is be vertical. Put a little star next to it though, because technically if you are a vertical line, do you pass the vertical line test where we can call you a function? No. So this is not a function, it's just a relation between x and y. Does anybody remember what the slope of a vertical line has to be when you have no change in that x? It is, start with a U, undefined. So he's not an increasing, decreasing, or constant function because he's not even a function. A vertical line doesn't pass the vertical line test. You plug one x value in, he spits out infinitely many different y values. It's not a function. Okay, perfect. So again, they're going to talk about that, I think, in a couple of questions on your homework, so I just want to make sure it was in your notes. All right. The best thing about a linear function is that it creates that straight line. And the reason it creates that straight line is because the slope, the average rate of change, is always the same. It always has the constant slope throughout any given pair of points on a line. So lines are straight because the slope, the average rate of change on any interval of x between any 2 points is constant. It's the same. If it didn't have the same slope in between two pairs of points, then the line would be jagged. It wouldn't have been straight. All right, so we can use the fact that the average rate of change, the slope of a linear function, is constant to prove whether or not a function is linear or nonlinear. So if they are ever asking you, is this a linear function? Is this a nonlinear function? All you need to prove is that the slope is always the same. If you can prove that that average rate of change remains constant, then you know you're working with something that is linear. If it doesn't stay the same, you're only working with linear information. So guys, look at example 1. Using the average rate of change to identify a linear function. So a strain of E. coli, known as whatever that is placed into a petri dish at 30 degrees Celsius and allowed to grow. The data shown in table 2 are collected. The population is measured in grams and the time in hours. Plot the ordered pairs, they already did that for you, so we don't have to worry about that, in the Cartesian plane and use the average rate of change to determine whether the function is linear. So guys, they want to know, as time goes by, the population of this E. coli is growing. Is the relationship between time and the population a linear relationship? Is this data showing a linear function? Well, you have to figure out if time is X and population is Y, here's your ordered pairs, you got to figure out, is the rate of change in between these ordered pairs constant? So grab 2 pairs of data points and let's find the change in Y over the change in X. Once you find the first slope, all you need the other slopes to do is match it. So I'm going to do 0.12 minus 0.09 over 1 minus 0. So it says it's going to be 0.03 over 1. So it's saying that the population is growing by 0.03 grams per each 1 hour. As long as all the other data points have the exact same slope, we're golden. It's a linear function. Let's find another slope. Change in Y over change in X. I'm going to grab the next 2 data points. So what's the rate of change in between the next 2 data points? 0.16 minus 0.12 over 2 minus 1. Uh-oh, now the difference in the population is 0.04 over 1. So now the rate of change has differed. Now it's growing by 0.04 grams per every 1 hour. So the minute you find out that 2 slopes don't match, you can stop. This is not a linear function. It does not have a constant rate of change in between each pair of data points. And you can see the graph of it. It's not exactly a straight line. It's definitely a little bit curved, almost parabolic in a way. So the graph alone could kind of give that away. So this is a non-linear function or a non-linear relationship. So again, all you're really doing is finding slope. You want to prove something linear? Find the slope. You guys okay? Nice and easy? Yes? Everybody home okay? All right, so I'll give you guys the next one. The next one says, the data in table 3 represents the maximum number of heartbeats that healthy individuals of different ages should have during a 15-second interval of time while exercising. Plot the ordered pairs in their Cartesian plane, they already did that for you, and use the average rate of change to determine whether the function is linear. So guys, find out if the relationship between age and the number of heartbeats while exercising has a linear relationship. So remember, age is your X and your heartbeats is your Y. Find the average rate of change. You guys can do it there and I'll do it here.
Would I have to do one for each of these?
So here's the thing. Technically, you have to prove that all of the data points have the exact same rate of change. But once you know what the slope is, like right now, the heartbeats are going down by 2.5 heartbeats for every 10 years of age. So what you would do is if you want to now visually look at the rest, can you see that all of the ages are going down by 10 years? Yeah, the change in the ages is all changing by 10. And then if you look at the Y values, is the change in heartbeats always going down by 2.5? So as long as you can see in the data, once you've seen one slope, that would be good enough for me. But you do have to prove it for all, Michael. The last 2 data points, maybe they don't have that same rate of change. So I wouldn't move on without at least looking at all the data points. All right, even if you don't calculate it for all of them. All right, does everybody agree that all of the change in y and changes x's is going to be going down by 2.5 over a change in 10? Yes. So now you could say, since all of the slopes are the same, this is a linear relationship. And when you graph it, you should see that perfectly straight line form, okay? So again, because all of the slopes are constant, you can say that this is a linear relationship. I'm just going to write down one more for you guys to have. All right, so again, it's all changing at the exact same rate. This is a linear relationship, a linear function between the age and the number of heartbeats.
So basically check all until proven non-linear.
Exactly. If you can find one to dispute it, it's not linear.
Will there be problems like that where it's like the last one?
Could be.
Oh, God.
Math is mean like that, Michael. It waits the last data points until you find out that the rate changed. But again, I think after a certain many, you can just visually start looking. I don't think you have to necessarily mathematically calculate it every single time. All right, here we go. It says straight line depreciation. Book value is the value of an asset that a company uses to create its balance sheet. Some companies depreciate their assets. Remember, depreciate means it's losing value, it's going down. They depreciate their assets using straight line depreciation so that the value of the asset declines by a fixed, a constant amount each year. The amount of the decline depends on the useful life that the company assigns to the asset. Suppose that a company just purchased a fleet of new cars for its sales force at a cost of $31,500 per car. So guys, that's what they started their value at. They started with a value of $31,500 per car. The company chooses to depreciate each vehicle using the straight line depreciation method over 7 years. So 7 years is extremely important to us. That's the amount of time they're going to give this car to depreciate in value all the way down to 0. All right, so think about it. In part A, it says, write a linear expression that expresses the book value of each car as a function of its age. So they want the value as a function of its age x, which means the age will be going into this function, and the value of that car will be coming out. That's how this function is going to work. Value as a function of age x. Age goes in, the function spits out the car's value. And it's depreciating, so the car's value should be going down as the age gets bigger. So guys, if you're going to write a linear function, remember, we're going to use y equals nx plus b as our go-to get-started formula. You need points. If you're going to write a linear function, you need points, and you need a slope. So at age 0, how much did the car worth? What was his original start amount? $31,500. So at age 0, he's worth $31,500. They have chosen to let this car depreciate over 7 years. So that means when this car is age 7, what will his value be? 0. He's going to depreciate out of value. So you've just created 2 ordered pairs. Now you can find slope. So the slope will equal change in y, 31,500, minus 0, which is that, over 0 minus 7 is -7. It makes sense if this is a depreciation function, the slope should be negative. The value should be going down per each year or age of its life. So now we can simplify this. The slope is actually 31,500 does divide by 7, and it's -4,500. If you want to put it over 1, you can, but you don't have to. All right, so if we want to write a linear function, y equals mx plus b, we just found the m, the y-intercept. Guys, the y-intercept, 0, b. 0 at age 0, what is the start value? 31,500. So you already know the slope, and you already know the y-intercept. So we're going to do value as a function of x is equal to our slope, -4,500x, plus the b, which was 31,500, the initial value of the car. Is everybody okay with that? Nice and easy, hopefully, yes? At home, are we okay? Okay, like I said, hopefully nice and easy. All right, then it says, what is the book of B? Graph it. We're not doing that. We're not graphing this huge numbers or anything. I would say plug it into your graphing calculator if need be, but we're good. C, what is the book value of each car after 3 years? Well, what are we going to do with 3 now that we have this great function? We're gonna plug it in. So what is the value of each car at age 3, after 3 years of being purchased by this company? And I believe you get 18,000 when you plug in 3. Each car is now worth $18,000 at age 3.
Ms. Marty,
Yes,
I have a question.
hit me. Is that you, Jay? What's going on, Jay?
Yes. How did you get the order pair 70? I understand how you got the 7 from 7 years, but how did you get the value?
Okay, because age goes into the function and value comes out. So think about like day 0, when they first purchased the car, when he wasn't any age yet. At age 0, what was the car worth? What was the start value of the car? $31,500. So you'll always be able to take that start value with an age of 0 as your first ordered pair. Does that make sense? Okay, and then you said you understand that age 7 he'll be worth 0? Okay.
No, actually, I don't understand that part.
Oh, I'm sorry. Depreciation means that it's going to have a start value. They're going to give you an amount of time that it's going to depreciate to 0 value. So at age 7, because it said it's going to take 7 years to depreciate, that car will be worth nothing to that company. Okay? All right, then it says interpret the slope. Well, guys, here's our slope. The slope is negative 4,500 over 1. I feel like this section's big on interpreting the slope. Well, remember, it was change in y over change in x. So it's change in value over change in age. So it's value over age. So according to this slope, it's going to lose $4,500 in value per every 1 year of age. That's what this slope is saying. It's going to lose $4,500 in value per every 1 year. Or if you go back to the original slope, it's going to have a value of $31,500. Over the course of 7 years, it'll go down to nothing. All right, and then the last one, when will the book value of each car be $9,000? So I want to know, what age will the car have a value of $9,000? Set the function equal. What number goes in to make 9,000 come out?
Would it be 5?
Yes, it is.
Okay.
Where's my function? Over there. And again, linear functions, we're not working with anything too heavy. Minus the 31,500, divide by negative 4,500, and you get x is 5. It'll take 5 years for these cars to have a value of $9,000. Is everybody okay? Nice and easy still? Everybody good?
Can you keep E up on
Yep.
there?
At home, are we okay? Good? Okay. I'm just gonna give you a second. And the last one. Excuse me. The last problem basically tells you exactly what you should be doing each time, but here we go. So guys, basically, it's a supply and demand problem. The quantity supplied of a good is the amount of a product that a company is willing to make available for sale at a given price. The quantity demanded of a good is the amount of a product that consumers are willing to purchase at a given price. So suppose this is the supply and demand functions. Notice, both the supply and the demand, they depend on price. The amount the company is willing to make depends on the selling price, and the amount people are willing to buy depends on the selling price. All right? It says the equilibrium price is defined as the price at which quantity supplies equals the quantity demanded. When supply equals demand is the equilibrium price. That is the equilibrium price is the supply, I think I just read that, at which S of P equals D of P. So they want us to find the equilibrium price of cell phones. What price does this cell phone have to be sold for to make the supply and the demand equal? So guys, that's nice and equal. Easy, set these functions equal and let me know what you get. So when does S of P equal D of P? And they basically told you to do that. So when does 30P minus 900 equal negative 7.5P plus 2850? right? Get your P's on one side, your numbers on the other, and you should find out that the price is equal to what? Anybody get it? If you have a calculator, it is 100. So the price they need to sell these phones at in order for the supply to equal the demand is $100. But hold the phone. It says find the equilibrium price of cell phones. We just did. The price is $100 to make supply and demand equal. Then they say, what is the equilibrium quantity? All right, the amount demanded or supplied at the equilibrium price. So guys, you just found out what's going to make the supply and the demand function equal. If you plug 100 into S or D, you're going to get the same output because this is when these functions are equal. So to find out the equilibrium quantity, how many phones are supplied or demanded at a price of 100, you have to plug 100 into one of these functions. It doesn't matter which one because 100 makes them spit out the same answer. So if you ask me, look at the two functions, pick your favorite, plug 100 in as the price, and see what the number of cell phones will be. I like S of P better, so I'm going to plug 100 into that. So you're going to get what? 3,000 minus 900, and you get 2,100 phones. So when you sell a phone at $100 each, the company will supply 2,100, and the demand by the consumer will be 2,100 phones. All right, the last thing, it says determine the prices for which quantity supplied is greater than quantity demanded. A company wouldn't want to do that. They don't want to supply more than is actually in demand. So they're going to want to know the price of a phone where their supply will be more than the demand. That's bad for the company. So they ask you now to find where S of P is greater than D of P. So when is 30P minus 900 greater than negative 7.5P plus 2850? Well, guys, you are solving an inequality now, so just be careful if you had to divide by a negative number. But we already solved this over here, right? You're going to get P is greater than 100. So if the price of the phone is bigger than $100, the supply will be more than the demand. So that's not good for the company. So they're not going to want to sell this phone for more than $100. Okay. All right, so guys, that's basically it. That is just good old linear functions. Just y equals mx plus b. We have this constant rate of change going on. And then you have your typical, I want to say, your mx plus b word problems, okay? I just want to warn you guys, for anybody, just because it's the shortened week, what we're going to do is I assigned you a 3.1 homework. It's pretty easy, guys. I think it's like under 20 questions, right around there. But I'm going to give you tomorrow in class to work on it, because I don't have any more problems to actually go over from the notes. So I may do tomorrow night at midnight, but you'll have tomorrow's class time to work on it because there's no sense rushing to keep starting new sections with the shortened week. So then on Wednesday, 3.2 is just a graphing calculator activity. So I'll show you that on Wednesday, and there's no homework to go along with it. So then you'll have no homework over the break. All right, so that'll be the game plan for tomorrow. So tomorrow, if you're coming in, I'll get you a Chromebook. You can work on homework. If you get it done tonight, great. It's your call. But that's the game plan for the week. We'll do homework tomorrow. We'll do 3.2 on Wednesday, and then we'll have a wonderful Thanksgiving. Okay. If you have any questions for me, please stay on the meet. Let me just double check the attendance really quick. Marissa, Casey, Mark. Yep. Chloe, Kayla, Javier. Am I missing Javier? Yeah. And you said, okay. All right, guys, you are good to go unless you have any questions for me. Have a great Monday. See you later. Anybody here have any questions for me?
So basically the homework isn't due tonight.
It's due tomorrow night at midnight, and I'm going to give you tomorrow in class. So some of you might be able to get it right done depending on what your day tomorrow looks like, but there's just no sense rushing through and starting 3-3 on Wednesday before we leave.
Is there 3-2?
3-2 is a graphing calculator. It's basically a scatter plot. I show you how to do it on your graphing calculator, but I don't assign homework with it because normally students wouldn't always have had a graphing calculator, even though people sign them out. And it's just something that I'd like you to be aware of, not necessarily something that you actually have to do yet. So I'll just show you that on Wednesday, and then we'll go for Thanksgiving.
All right.
Venus Hardy.
Hey, Jack, what's going on? Sorry, I didn't know you were there.
I'm so sorry. I switched to all virtual, and I just wanted to make sure, like, I don't know if my guidance counselor, switched that yet, but with, like, the rising, like.
Oh, I don't blame anybody. I hate to lose people because I still like coming in as dangerous as it's getting, just selfishly.
It's
So,
okay.
is Dave staying home too, or is both of you staying then?
Yeah.
Okay.
We're both probably just gonna, since my parents, like, they're
I
a
don't blame you, Jack. Safety first.
Yes, thank you so much,
All right.
Miss Hardy.
See you later.
Bye-bye.
I don't mean to be like too strict or anything, but I genuinely think we should be all virtual until we're
I do.
completely out of the way.
I know. I think so too. It's just selfishly, I find it easier to work when I'm coming in.
Yeah.
It's also easier to learn.
Yeah, I think so too.
For some reason, it's easier to organize when everything is like outlined, because it's like, this is my base,
I know.
and it's not moving.
Yep. I just feel a lot better. I feel more normal being here. See you later.
Yeah.
Even though it's
I
definitely
just
not
feel like
normal.
running around, like all the time, you know?